So the mission of the Neurophotonics Center is really to push the frontiers of the technology development so that we can really address the leading edge questions in neuroscience. The Neurophotonics Center is an environment that's embedded inside a biomedical research center, here the Servo Brain Research Center. It's a joint initiative between the Optics and Laser Research Center and our Brain Research Center. We put the common space inside the Biomedical Research Center because I really wanted to immerse the physicist into a biomedical environment.
The Canadian Neurophotonics platform is made up of researchers from universities all over Canada, but the hub, the core of the whole platform is right here at the University of Laval. One of the reasons why I think the Canadian Neurophotonics platform is so powerful and such a good example of why it's important to bring together such a wide variety of resources is that neuroscience is extreme biology. All of the challenges are just greater in neuroscience. The brain is the most complicated organ. It's buried under a skull that it's difficult to get light through, it's difficult to access. It's soft and squishy and delicate. Things happen very quickly on the millisecond timescale. So it really is extreme biology. And no one person, no one lab, no one discipline of science can really tackle this extreme biology by themselves.
The Biophotonics program is a graduate program for both master's and PhD students. It trains undergrads with expertise in either life sciences, be it biology, biochemistry, microbiology, or physical science, chemistry, optics, or engineering. The program is geared towards research, so the students have their own research project, but it's also very collaborative, so students with different expertise and trainings work together to solve complex problems.
What is specific with training of a PhD student in a center like the Center of Neurophotonics is this multidisciplinary nature of the training. So we're expecting students to have a background both in physical science as well as in biology, more specifically in neuroscience.
The biophotonics programs at Université Laval is different than other programs from other universities in that it requires a mandatory co-mentorship from a PI from the life sciences and a PI from the physical sciences. So this ensures a true transdisciplinary training.
I had the chance here to collaborate with neuroscientists. Basically that helped me a lot because I was able to design systems with a real application in mind. And they also helped me to test it in real conditions. That's something you cannot do if you are a physicist working only on physics systems all alone, but that's a really good advantage in here.
As a postdoctoral fellow here, I learned a lot on neurobiology. I developed a new technique, what we call intelligent nanoscopy. So we combine machine learning and artificial intelligence to super resolution microscopy, which allow us to look at very, very small structures in the brain in the range of the nanometer scale, so it's extremely small, and be able to control automatically our microscope.
I definitely learned a lot from my mentor, and I should say mentors because I was lucky enough that I had two of them, one in physics and one in biology. I've learned technical aspects from them, how to prepare presentation, to write in a way that everybody understands. Being in a field where you need to deal with physicists as well as biologists, you always need to make sure everybody understands and everybody's on the same page. So this is something they taught me along the way and that I'm using all the time in my job right now.
For me, the added value to work with biologists at the Neurophotonics Center is that we work with those who have their hands in it. They're in the lab and they can express all the problems they have and all the challenges they encounter directly to us so that we can discuss possible solutions.
I immediately found a group here that was doing research that was directly relevant to the kinds of things that I was doing and really using state-of-the-art techniques and applying them to ask fundamental questions. And so as a scientist, that's where you want to be.
At the Neurophotonics Center, One of the core objectives is really to train a new generation of scientists at the interface of physics and biology. I really believe that these new scientists that are trained at that interface are the ones that are going to be leading innovation.